As one of the missing Century Series fighters, the XF-108 long-range interceptor had great promise. In the North American tradition, the F-108's sleek lines and graceful shape evoked a sense of speed and unbridled performance. The North American P-51 Mustang is undoubtedly one of the greatest fighter aircraft of World War II. Designed after the war began, it was produced in huge numbers and saw action on every front. Like the British Spitfire, the Mustang's sleek, purposeful lines and outstanding performance made it one of the most recognizable fighters of the Second World War. It was also the beginning of a long line of superb fighters built by the talented team at North American. North American Aviation is regarded as one of the great aircraft companies. Between 1935 and the 1960s, North American enjoyed a golden era of design and production. Led by James H. Dutch Kindleberger and John Leland Atwood, the list of successful North American aircraft is remarkable. When it came to fighter designs, North American produced some of the most impressive fighters of all time. The P-51 Mustang is considered by many to be the finest fighter of World War II. This was followed by the remarkable F-82 twin Mustang, which saw action during the Korean War. When Soviet MiG-15s appeared over the skies of Korea, the US were ready with the outstanding F-86 Sabre. And as speeds increased, North American answered with the all-supersonic F-100 Super Sabre. It was an impressive record, but not all the fighters submitted by North American made it to production. Sadly, the company's last fighter design never made it past the mock-up stage. As one of the missing Century Series fighters, the XF-108 long-range interceptor had great promise. In the North American tradition, the F-108's sleek lines and graceful shape evoked a sense of speed and unbridled performance.
In September of 1958, I had been promoted to full colonel on my assignment in the Pentagon, and I asked for the assignment to be the program manager of the next fighter in development, which was the F-108. And my boss at that time, General Hal Estes, picked up the telephone and called Wright Field, discussed it with General Haugen, and in a matter of 5 minutes, I was then named the new program manager, which was in its early stage of development. It was the sister airplane to the B-70, the XB-70.
All modern fighters have their origins in a design requirement. Those conditions have many influences, and while not directly part of the XF-108 story, another development in the 1950s played a direct role in the history of the elusive Mach 3 interceptor. During World War II, radar proved vital for any effective air defense system. Ground-controlled intercepts became the norm and integral to both day and night fighter operations. After the war, the United States embarked on a program to enhance and improve radar technology. In 1952, the US Air Force initiated development of the SAGE system, the semi-automatic ground environment was designed to protect the airspace over the United States and Canada. SAGE was an integrated set of radars, surface-to-air missiles, and interceptors, all tied to a vast network of digital IBM computers and a long-distance communication system. In terms of complexity, the new SAGE system was the most technologically demanding project ever attempted at the time, even surpassing the development of the atomic bomb. In 1956, the first SAGE Direction Center came online at Mach Air Force Base, and by 1962, the system was complete. At the heart of the system were 24 hardened concrete direction centers. When one of the radar sites scattered across the US detected a Soviet bomber, that information would be passed to one of the direction centers. From there, friendly fighters would be dispatched or air-to-air missiles launched. The SAGE system proved to be a marvel of technology and was remarkably reliable. Unfortunately, the interceptors being developed at the time could not fully exploit the range and warning time given by SAGE. The idea of intercepting incoming Russian bombers well before they threatened the key industrial areas of the US and Canada had great appeal. That's when the long-range Mach 3 XF-108 was born.
One of the problems with the North American continent, because you're looking at Canada as well, is it's a huge area to defend. And although in theory Russia's a long way away, if you come directly over the North Pole, it actually cuts that distance down quite a way. So to find a way of protecting this, and really to do it thoroughly and make sure you don't miss the enemy bomber, is quite difficult. And the objective of SAGE was to have radar stations based all over the country, so you've got a constant plot of what's moving into the area, moving into airspace, and then the weaponry to deal with it if you have an enemy bomber to actually take out. And that's either surface-to-air missiles from shorter range or these long-range interceptors to deal with them much further out.
The new SAGE system was a force multiplier, but the fighters in production at that time didn't have the range or firepower to fully exploit its capability. For some, the most logical solution was to turn a B-47 Stratojet medium bomber into long-range interceptors, armed with dozens of air-to-air missiles. This idea, however, was never taken seriously. While the Pentagon agreed with the need for a long-range interceptor, no development program was put forward. Air Defense Command was, however, very insistent, and in October 1953 attempted to gain formal Air Force approval for a new interceptor. They also added some overly ambitious requirements for their new aircraft. The first was the capability to attack an incoming bomber from both the rear and from head-on. The radar had to have an airborne moving target indicator and an anti-chaff synchronizer. Air Defense Command also wanted a 3-bomber per kill mission. Armament included 270 2.75-inch rockets, 18 Falcon missiles, and 3 nuclear rockets. It was a tall order. Either the Air Defense Command had little faith in the reliability of the weapons, or the ability of the pilots to shoot straight.
Well, the air defense system that we had in this country in the early days, we had the F-101 built by McDonnell. We had the 102 built by Convair, and the 106. These were all air defense fighters, including the F-86D model. That was another air defense fighter, a night fighter. And so, but those airplanes were what we call short-legged. They had limited range, and they were dependent upon the ground environment radars to pick up any the incoming targets, so they can then direct the fighter to intercept that target. Whereas the 108 was going to be a big step beyond all those capabilities, and would be able to fly at 3 times the speed of sound at Mach 3, and would be able to sweep out large areas like 200 miles ahead of the airplane, and they wouldn't be dependent upon the ground environment.
The XF-108 interceptor was a shining example of a weapons program caught in the push and pull of inter-service rivalry. Various Air Force organizations and the Air Defense Command went back and forth, each pushing their own vision as to what would be the best aircraft. For Air Defense Command, time was the critical factor. They wanted a fighter operational by January 1958, which meant eliminating any industry competition. To speed the process, unsolicited designs were proposed. Two were considered. One was from Northrop in the form of a Super Scorpion, and the other a two-seat version of the F-101 Voodoo from McDonnell Douglas. Back at Air Force headquarters, the first requirements for a new fighter were being sketched out. It would be an all-weather, twin-seat, twin-engine aircraft with a radius of 1,000 miles. It would also operate inside the SAGE network with the capability of independent interception. Studies conducted by the Wright Air Development Center concluded that both the Super Scorpion and the two-place F-101 would not provide the needed performance for a long-range interceptor. Air Force headquarters realized that any new fighter would not be operational before 1960. To expedite the process, requests for proposals were issued in May 1954. 7 proposals were received, but none were really satisfactory. Finally, after what seemed like an endless struggle between Air Defense Command and Air Research Development Command, a new requirement for a new long-range interceptor experimental was issued by ARDC. The new fighter was to have a speed of Mach 1.7 at 40,000 feet with a 1,000-mile radius of action. On October 11, 1955, study contracts were issued to Lockheed, Northrop, and North American. Due to funding constraints, the Air Force was forced to select a single contractor, with North American coming out on top. On June 6, 1957, North American was issued a contract for 2 prototypes for a long-range, high-performance interceptor, designated XF-108. This would be North American's last fighter design. Even at this stage, arguments continued as to whether the new fighter should be a long-range or a medium-range interceptor. The final answer would be both. The F-108 was designed primarily as a long-range interceptor with a medium-range capability. Not surprisingly, the medium-range idea was largely ignored. There were also reports the F-108 was to be a long-range escort fighter for the new B-70 Valkyrie, but this never was the case. At the heart of the F-108 was its new airborne radar system. Both Hughes and RCA had fire control systems that would work with the F-108. Both were evaluated, with Hughes winning the contract. The F-108 long-range interceptor was proving extremely expensive. By the beginning of 1958, it was burning through more than $3 million a month, and that didn't include the effort by Hughes and the fire control system. Even at this point, performance estimates were still very rough, but encouraging. Powered by 2 General Electric J93 engines, each developing 38,000 pounds of thrust, the new F-108 was to be a long-range, high-altitude supersonic interceptor capable of destroying supersonic enemy aircraft. Unlike the XF-103, which was designed for high Mach dash speeds, the F-108 would cruise at Mach 3 at 70,000 feet.
The power plant for the F-108 were 2 General Electric GE-93 turbojets, each of them creating 23,700 pounds of thrust. There was 3 GAR-9 air-to-air missiles, which eventually would be redesignated AIM-47, and they would have been carried in an internal weapons bay. All at weight is 100,000 pounds, and the aircraft was designed to fly towards Mach 3 at altitudes of up to 80,000 feet with a phenomenal rate of climb. And these were performance figures really for the time. Well, even today would make you blink. They're so phenomenal. For the 1950s, it's 50 odd plus years ago, quite remarkable figures. And as needless to say, the actual process of designing and developing this would cost a lot of money and would actually bring the aircraft down in due course.
In 1958, a new wrinkle was added to the F-108 program. As part of their original bid, North American proposed sharing components between the F-108 and the XB-70 bomber. In theory, it would lower the costs for both aircraft, but in reality, it was a decision that everybody would later regret. The F-108 program spent a great deal of time and money testing new materials and developing methods of fabrication from advanced alloys. In addition to the stainless steel honeycomb panels, the F-108 investigated various metals, including hardened steels, beryllium, and titanium. It also developed both cloth laminates and other composites. Many of these technologies would benefit the aerospace industry as a whole, but would never be used on the F-108. North American was also designing an escape capsule for both the F-108 and the XB-70, releasing a canopy and successfully ejecting from an aircraft. Streaking along at 2,000 miles per hour at 70,000 feet was next to impossible. For the F-108, both the pilot and radar operator would have individual escape capsules. When trouble struck, an internal clamshell door would slide up over each crewman, completely enclosing them. The entire capsule would be ejected out of the aircraft. It was not a new idea and came courtesy of Republic's XF-103.
The escape capsule was another shared. We would have had the same crew capsule in the 108 as the B-70 did, which later on was used, by the way. And so I always have felt a close connection to the B-70 program as a result of the interrelationship of the two. They use the same technology.
During this period, new studies and ideas were continually being put forward. One study evaluated the effects of installing an aerial refueling capability. Others looked at thrust reversers, a boron-based high-energy fuel instead of the regular JP6 jet fuel, and whether different engines would improve performance. Even with all the additional studies, progress was being made. The Hughes ASG-18 radar system had passed the mock-up stage and was considered feasible and acceptable. The ASG-18 was to be the first pulse Doppler radar developed in the United States. It would also have a look-down, look-up capability, but as powerful as it was, it could only track one target at a time. But troubles began to mount and delays set in. On November 19, 1958, the operational date for the F-108 was pushed back to mid-1963, and the number of prototypes was cut from 31 to 20. The first flight was also delayed by 3 months and scheduled for April 1960. There were also mounting problems with the all-missile armament. The F-108's armament consisted of 3 Hughes GAR-9 missiles. Large and highly advanced, the GAR-9 soon ran into a series of delays and changing requirements. The Air Force, unhappy with the progress of the semi-active homing radar, asked for a dual system consisting both of a semi-active and infrared seeker. This was a major headache for Hughes. The original missile had not been designed for 2 seekers and would have to be larger. Rocket motor development was also running into problems. By the time the GAR-9 was actually built, it had less power and was only capable of Mach 4, far from the planned Mach 6. Fortunately, much of what was learned developing the GAR-9 would be used for the US Navy's successful AIM-54 Phoenix missile.
The F-108 as an air defense fighter, being able to fly at 3 times the speed of sound and having a new radar, 5 kW in power, was far more powerful than any other airborne radars, and is developed by Hughes Aircraft along with the GAR-9 missile that was developed by Hughes as well, an air-to-air. These 3 GAR-9 missiles would be in a missile bay underneath the 108, and after intercepting a target of Russian bombers that are coming over the North Pole region, they could be launched, and of course the atomic warhead wouldn't be like the atomic warheads we think of in our ballistic missiles. They're scaled down, so it wouldn't be of equivalent size in the actual destructive capability. But it was the first of its kind in that era to even be conceived on an air-to-air missile.
In January 1959, the F-108 mock-up was ready for inspection. On January 5th, the Air Force Development Engineering inspection took place, followed by a full inspection on the 26th. A notable member at the time of the inspection team was Double Ace Lieutenant Colonel Robin Olds. He would later become a triple ace during the Vietnam War. In addition to the full-scale mock-up, a metal mock-up of the forward fuselage was also on display.
I spent a great deal of time at North American, and we had a mock-up of the airplane built where we called in our technical team and also the air defense people so they could have their inputs on how the cockpit might best suit them. So we had an ongoing program that, of course, I was hoping that it would continue.
First flight for the Mach 3 F-108 was scheduled for March 1961 with an Air Force requirement of 480 aircraft. As with all combat aircraft, the F-108 was being viewed as more than just a long-range interceptor. One idea was to use the F-108 as a gap filler for the distant warning radars on the dew line. Based at remote Arctic airstrips, the idea was to keep a number of F-108s constantly airborne in order to eliminate gaps in the radar coverage. On May 15th, the aircraft was named Rapier, continuing a short-lived tradition of naming North American fighters after swords. As the project moved forward and support for the F-108 gathered momentum, funding became an issue. As good as the F-108 promised to be, the cost of the program would eventually overshadow all of the technological advances. As budgetary constraints began to take hold, there were other forces at play that would doom the F-108. The nightmare scenario of Soviet intercontinental ballistic missiles raining down on the US homeland in the early 1960s made the Mach 3 interceptor obsolete. Projects that included the F-108 and the XB-70 were soaking up funds now deemed necessary for America's own ICBM program. ICBMs were not only cheaper, faster, and more reliable, they were completely invulnerable to interception.
There's strictly a money reason why the program was canceled, although later on, you see, we were competing in the Cold War with Russia, and at that time, the requirement for the 108 was built upon worrying about the Russian bombers coming over from Russia over the North Pole, and we'd be able to counter that by flying over Canada and being able to stop any intruders from coming from the north. Well, later on, the intelligence didn't support the bomber threat of the Russians to the extent that we originally thought. It was, again, a question of intelligence where they didn't have limited knowledge, and they extrapolated, obviously, to make sure that we were able to counter anything that might develop. But fortunately, the Cold War didn't go any further than it did, and we never needed an airplane for air defense purposes to that extent.
On August 21, 1959, the F-108 was placed in the strictest austerity category. It would be the final nail in the coffin, and on September 23, 1959, the F-108 was officially cancelled. The harsh realities of the Cold War finally caught up with the F-108 Rapier and the dream of a Mach 3 fighter. Its legacy, however, continued. The Hughes-developed radar and weapon system found their way into the YF-12, the fighter version of the famous SR-71 Blackbird reconnaissance aircraft. 3 YF-12s were built and proved to be the only Mach 3 fighter to successfully fly for the US Air Force. Like the F-103 and F-108, the YF-12 program was cancelled in February 1968, ending once and for all the quest for a Mach 3 interceptor. In the end, North American adapted much of what was accomplished with the F-108 and put it into the A-5 Vigilante. It was the world's only Mach 2 carrier-based bomber and eventually saw extensive service with the US Navy as a reconnaissance platform during the Vietnam War.
Even though the XF-108 Rapier wasn't built, it contributed a lot to aeronautical knowledge, and it contributed a lot to the in-house knowledge of the North American design team in Southern California that was working on this aircraft. And one of the things that they did as a result of acquiring all this knowledge was to design and develop for the Navy an aircraft called the A-3J Vigilante, later called the A-5. It was designed initially as a long-range nuclear bomber to operate from carriers in the days when the Navy was searching for a nuclear role for its aircraft carrier fleet.
North American would never design another fighter. Its talent and expertise would soon be channeled into the space race. Amazing aircraft like the rocket-powered X-15 would break records and soar to the edge of space. Its space division would go on to design the Apollo space capsule, and in 1967, North American merged with the Rockwell Standard Corporation to become the North American Rockwell Corporation. This merger would produce the world's first spaceplane. Ordered by NASA in 1972, the space shuttle would revolutionize spaceflight and usher in a new era of flight.
At this time, I was told that I had been made a brigadier general. I learned later that General LeMay was in a meeting with Secretary McNamara. At one point in time, General LeMay was director of research at the Pentagon level, at the Air Force level, and under him he had a lieutenant colonel by the name of Robert McNamara. So this was a subservient individual to four-star General LeMay. Well, now the roles are reversed all of a sudden, and that's when McNamara asked LeMay, how many general officers do you have running these billion-dollar programs? And the B-70 at the time was a $1.4 billion aircraft program. So I got noticed immediately that I was now running the XB-70. And it was kind of startling because all of a sudden I had to shift gears from being a director of laboratories to a program director, which is entirely different. The B-70 program at the time had been programmed to develop 3 aircraft. The number 3 aircraft would be the bombing navigation version. The first aircraft was pretty well handmade. The second airplane was made much better. And of course, the third airplane would have been perfect with the bomb nav system in it. But it was canceled when it was about 75% completed. In fact, I like to tell the story that characteristically in the Air Force, the bombing navigation system is traditionally late, 1 or 2 years late. The airplane is sitting on the ramp ready for that to be put in, and it's waiting for the delivery. In the case of the B-70, believe it or not, the bombing navigation system was on the dock ready to be installed, and the airplane it was to be installed in was canceled. The wingtips rotated downward at Mach 3 or any supersonic speed because it contained the airflow underneath the aircraft instead of dissipating it out to either side. So the airplane was riding on the same thing a canoe does when it's powered. You know, it's up there on a crest. And that's the compression lift aspect of it. The engineers that designed it at North American figured that was what would happen, and they confirmed it in wind tunnel tests. So it's nothing more than containing the airflow underneath at supersonic speeds. The airplane itself was a monster, really, a huge airplane, and it was capable of flying to Mach 3. At that same meeting, when we broke up, General LeMay pulled me to one side and said, "Do you think it's ever going to go to Mach 3? And I said, "Yes, sir, it will. It's going to hit Mach 3. In fact, it went to Mach 3.2. And so actually it fulfilled what the intention was. And I watched the program and progress of the B-70. It was coming along fine. The big problem was fuel leaks. When you consider how huge the fuel tanks were and trying to get them to seal properly from leaking fuel, it was just an impossible program. I happen to know, because I was cleared for the information that was being accumulated by the SR-71, that they had solved their fuel leak problem. And I found out that they had a certain contractor who could do it. Then I passed this information on to the North American people. They were very suspicious of where I got the information and how, and I wasn't able to tell them. But I was able to tell them, go to this contractor and he will solve your problem. Well, it was a 1-year delay in production of that aircraft, believe it or not, because of fuel leaks. We'd put a certain type of material down on in the in wings, and then some clown without canvas boots would walk across it and tear it up. Now you got to go through all the curing, applying, and so forth. That's what delayed the airplane considerably. Our big problem was keeping the surface of the airplane properly established. We had trouble with tires. The tires would come up into the wheel well, and they were eventually exposed to about 300 degrees Fahrenheit and would burst, and so they'd have a problem landing with them. So Goodyear had to design different types of tires for the B-70, including interwoven aluminum threads to keep them from rupturing. So it was a nightmare temperature-wise. I wanted to be on the first flight when it flew, and it would be flying out of Palmdale and then land at Edwards Air Force Base, where it would continue its flight test. The chief engineer, Mr. Swanson, said, okay, we can rig up a seat belt, safety belt, on the water tank that's directly behind the two pilots, and we'll equip you with a parachute in case you have to bail out, because the two pilots will be going out in capsules. So he said, I want to show you one thing, however, before we make that decision. And he took me up into the cockpit, and he asked me in a little door to look back, and I'm looking back at an intake with 3 engines embedded in it, and he said, when you go out, where do you think you're going to go? And I said, well, never mind being on the first flight, forget it, because that huge, like a big house, would have sucked me in. Obviously, I wouldn't have ever been able to survive the crash. The first flight, all the tires blew out. There were streams of flame from going behind the airplane. All of them blew out, because the sensing device locked up all the wheels instead of taking the pressure from the cockpit and braking them gradually, as you now have on automobiles and so forth. They locked the minute they applied pressure, brake pressure to the both sides. The wheels locked, the sensing device malfunctioned, they locked, and they blew them all out. I was on the midpoint where they landed at Edwards. I rushed over before they got. They flew about 30 minutes or so in the air and just tested out general characteristics of the airplane. And I saw that airplane land, a beautiful landing, and all those tires blew out. Well, the XB-70 was a favorite punching bag by Secretary McNamara. For some reason, he was convinced we didn't need the B-70 because of ballistic missiles. They would gradually replace any bomber effort. Secretary of Defense decided he didn't want to put the XB-70 into production. Then he suggested we continue the program until expiration of the funds to contribute technology to a so-called national supersonic transport program. So we did continue with the 2 aircraft, and of course the second aircraft was involved in a midair collision, and this was when I was in Japan with 5th Air Force. And it was just one of those tragedies that never should have occurred. And a lot of people were disciplined as a result. A GS-15 civilian, which is as senior as they get at the time, was reprimanded because he permitted a so-called photo flight to be authorized with 5 aircraft involved. the B-70 leading it, all equipped with General Electric engines. And so General Electric wanted to capitalize on this, and unfortunately the NACA pilot, NASA now, in a 104 got in too close to the overflow of the huge wing in the B-70 and was pitched up. His aircraft was long enough to take the tips off of the top of both rudders on the B-70. And I had chased the B-70 on a flight in a B-58, which has a lot more inertia. And I got in very close to the wing. When you're flying formation, you normally try to pick a point that you concentrate on to judge your relative motion. It was huge looking at the B-70 wing, and it was tough really to concentrate on any particular point. So I felt being sucked in to the flow over that wing, but the B-58 was large enough on its own that I got out of it. And I think that's what happened to the 104. It didn't have enough inertia and so forth to get back out once it got sucked in and it pitched.
More than 1/4 century after its maiden flight, the XB-70 stands as one of aviation's greatest achievements. This is the XB-70 Valkyrie, a supersonic heavy bomber that featured design innovations decades ahead of the planes of its time. Yet, this revolutionary aircraft never went into service, because while it was being developed, the strategic picture changed. Designed as a replacement for the Boeing B-52, the XB-70 could travel at 3 times the speed of sound, employing technology that was well ahead of its time. The XB-70 is one of the best aircraft designs that never went into production. A decade later, a similar fate almost befell this plane, the B-1 bomber. Apart from modifications to the engine intake, the B-1B seen here looks very similar to its controversial predecessor, the B-1A heavy bomber. However, because of the evolution of technology, the B-1B in many ways was a very different aircraft. Probably the biggest single step forward in the search for new technology to gain higher speed came with the advent of the jet engine. Although pre-war Germany first utilized jet power, American engineers also tested the concept on experimental aircraft before the war's end, with aircraft like Bell's Aerocomet. The first major development of the post-war year was the record-breaking Bell X-1 rocket-powered experimental aircraft. Dropped from a Second World War bomber on December 9, 1946, in the hands of test pilot Chuck Yeager, the X-1 broke the sound barrier for the first time. Further development produced the X-2, which flew faster and higher than its predecessor. The quest for higher speed put phenomenal stress not only on the aircraft, but also on their pilots. The risk of even a minor malfunction at the speeds now being attempted was enormous. Much of the data gathered by the X-airplane tests was used for military objectives. Faster aircraft would be harder targets to hit. Some of the lessons learned from the X-airplane program were applied to American fighters and bombers. With the Cold War on, stretching the boundaries of speed and distance had become a matter of national security. By the mid-50s, the Strategic Air Command, known as SAC, was deploying its first all-jet long-range heavy bomber, Boeing's B-52 Stratofortress, a giant plane with 8 jet engines suspended below fully swept wings. The B-52 could fly at speeds of 600 miles an hour with a large payload. But although the B-52 was one of the major successes of post-war aviation, it was not supersonic. The next step in the quest to increase the speed of bomber aircraft came with the B-58 Hustler. This delta wing was developed by Convair to produce a bomber aircraft which could actually fly and sustain at supersonic speeds. But to attain this performance, the plane had to be relatively small and could only be classified as a medium bomber. During the early 1950s, when Soviet America tensions ran high, SAC wanted a bomber at least as large as the B-52, but faster than the Hustler. This was a very tall order for engineers to meet. Taking a heavy bomber past the sound barrier required a phenomenal power source. Temporarily discarding normal jet power as inadequate, aviation companies looked towards two alternatives. The first was nuclear power, used to successfully propel submarines. Convair converted a conventional B-36, not unlike this one, to carry aloft a fully commissioned nuclear reactor. The crewmen were insulated by lead shielding, and although no attempt at this stage was made to transfer power to propel the aircraft, tests were carried out in earnest. Various designs were put forward for bombers which would at least in part be nuclear-powered. However, the biggest problem here was the ramifications of a nuclear-powered plane crashing in a populated area. Another proposal to boost power would be equipping bombers with external tanks of fast-burning zip fuels, such as boron. Prior to the plane making its final dash to its target, the enormous fuel tanks would be dropped, lightening the aircraft for attack. But an ingenious solution to the problem came forth from North American Aviation. The company had refined the concept of compression lift. Their plan called for mounting 6 enormous jet engines in a tapered shape under the aircraft, thus forcing air away from the center section at high speed. The design also allowed for this air to be trapped by the outer edge of the wing when it was lowered. The compressed air would act to lift the aircraft and help propel it 3 times the speed of sound. The design was given the name XB-70, and SAC approved it for development in December 1957. North American had a long string of successes, including the development of the twin-engine supersonic Vigilante bomber for the US Navy. This aircraft combines speed and bombing capacity never previously available to carry it. But now, having put forward the compression lift concept for a high-speed bomber, North American's big problem was heat. Wind tunnel tests proved the theory could work, but the great speeds the plane would fly at would produce such heat that all conventional materials would warp. To tackle the problem, North American employed a honeycomb sandwich material made from stainless steel. This offered strength and dissipated heat. After 12 months of testing designs and mock-ups, an order was placed for one XB-70. But the aircraft, now called the Valkyrie, was in for a stormy time. But at least the concept was still alive, and its proponents hoped it still might ultimately be accepted for military use. By 1963, at least one aircraft was well underway. The first XP-70, serial number 20001, must have been an awe-inspiring sight for those lucky enough to see it. But it was not until May 11th, 1964, when the press and public were given their chance to marvel over North America's sleek white wonder. Brigadier General Fred J. Ascani, who directed the B-70 System Program Office, described the plane's various features.
Most of the structure in the wings and fuselage is of stainless steel. These are our now famous honeycomb core sandwich panels, and many of the outer skins on these honeycomb panels are as thin as 7/1000ths of an inch. The two-man crew will sit side by side. The crew station in this position is about 20 feet above the ground. All of the space aft of the crew compartment is taken up by fuel, both in the fuselage and in the wing.
Before the XB-70 was poised at the downwind end of Palmdale's 12,000-foot runway for its first flight, numerous ground tests would have to be performed. Shortly after its debut to the public, the aircraft was again up on jacks, while its electrical and hydraulic support systems were thoroughly tested. All moving surfaces were subject to vigorous testing. All flight controls, including the forward canards, the elevons and rudders, were fail-tested and tested again. Like so much of the XB-70, the landing gear, which had to support the plane's phenomenal weight as well as the added stress of landing and takeoff, was for the time a unique and brilliantly designed feature. The forward twin wheels were conventional, but the support gear was required to rotate as well as fold the four-wheel bogie mechanism, which was stored in the limited space available. The whole process of extending and retracting the clever but complex gear could be achieved in little over 20 seconds. All of the many complex tests that took place during the weeks before the first takeoff were recorded in a special flight test instrumentation package. A self-contained airborne unit. This device was the first of its kind. It was carried in the aircraft's bond bay, and remained with the plane for ground taxiing and flight tests. The XB-70 prototype was also subjected to vibration tests that were designed to expose the gigantic fuselage and wing surfaces to the effects of vibration far beyond the point it might encounter in flight. As the aircraft test proceeded, aircrews were introduced to some of the engine's characteristics. Here at the Arnold Engineering Development Center in Tennessee, a J93 engine was set up in a simulation of the Valkyrie. The engine was installed in a test chamber to give the flight crew their first experience with its enormous power. The conditions were artificial but similar to what the crew would experience in flight. Seen here is Al White, North American's chief test pilot, the man chosen to command the XB-70's maiden flight. With him is Air Force Colonel Joe Cotton, the co-pilot for much of the early test program. The backup crew shown here are Van Shepard, from North American, and Lieutenant Colonel Fitzhugh Fulton. For months, these men were embroiled in the business of learning how to fly the world's most advanced and ambitious aviation project. By early September, most of the exhausting static tests had been completed. Now, the most revealing tests would begin. Tests with the aircraft in motion, then, eventually, tests of the XB-70 in flight. Before the engines were fired up, the complicated in-flight recording systems were primed to record every technical event as it occurred. This view of the Valkyrie gives a clear picture of what was to become known as the six-pack tightly grouped together. This phenomenal powerful combination of 6 jet engines were to propel the Valkyrie to speeds considered impossible only a few years before. Now, hundreds of mechanical functions were checked. They would have to perform perfectly if the Valkyrie project was to succeed. The aircraft was removed from all external power sources. After a series of taxi runs, pilots and technicians were satisfied that the Valkyrie was ready for its maiden flight. On September 21st, 1964, the XB-70A positioned itself at the end of the Palmdale runway for a historic moment with North American Aviation and the United States Air Force. Here, as planned, White and Cotton were in the cockpit. At exactly 8:38, the Valkyrie took to the air for the first time to begin a series of epic-making test flights. Accompanied by a single chase plane, simple routine checks were made as the pilots experienced the ways of the Valkyrie in flight. One of the first tasks was to retract the aircraft's advanced landing gear, but the mechanism failed to respond. With hundreds of millions of dollars of high technology in his hands, White set the landing gear back into its original position. The gear slowly responded to the cockpit control. Clearly, The first tests were to be made wheels down. Nevertheless, an alternative plan was available, and the plane continued on its maiden flight, although one engine was shut down when a warning light flashed. Over 60 minutes of valuable testing was gained by the time the aircraft headed back home to Edwards Air Force Base.
20 feet. 30. 20. 10. 5. And you're on. Beauty.
On landing, one of the rear brakes locked, setting that landing gear on fire. Sitting 20 feet above the ground, with the aircraft handling impeccably, the crew had to be told to the fire by the chase plane. Two weeks after its first flight, with its landing gear, engine, and brake problems all resolved, the XB was ready for its second trial. On an early autumn morning, pilot Al White rotated Test Air Vehicle No. 1 into flight. This time, there were two chase planes so the landing gear retraction could be viewed from both sides. A second attempt was made to lift the gear in flight. Again, anxious moments passed as the chase plane's crews watched. Now, with the landing gear stowed away, the Valkyrie could begin tests at higher speeds. As the plane climbed to altitude, a warning light flashed in the cockpit, alerting the pilots to a minor failure in one of the hydraulic systems. As a precaution, White lowered the landing gear again and pointed the aircraft towards an alternative destination, Rogers Dry Lake, which proved the security of an 11-mile natural runway. The approach was smooth, the brakes operated effectively, and the Valkyrie made a perfect landing. After the flight, it was learned that a fractured pipe had set off the warning light. but considering the enormous complexity of the aircraft, this and the other problems encountered were hardly unexpected. The pilots reported that the Valkyrie behaved in a predictable and comfortable manner. They were coming to terms with the world's most powerful aircraft. While the first prototype was being tested, construction of the second XB-70 proceeded steadily. The massive tubular fuselage was married to the six-pack. The enormous white fins that would direct the Valkyrie were already in place. Lessons learned from the construction for the first prototype rapidly reduced the manufacturing time of Air Vehicle Number 2. The second aircraft differed from the first in a subtle design change. An extra 5-degree dihedral was added to the wings to improve flight stability. Here, one of the massive wingtips is being fitted. This unique feature was, until recently, the largest single moving surface unit fitted to an aircraft. The presence of these wingtips would enable the unique compression lift principles to propel North American's brainchild into the trisonic stage. Back at Edwards, Air Vehicle Number 1 was rising into the sky again. Now, White Cotton and the engineers had sufficient confidence to push the Valkyrie beyond the speed of sound. On no less than 3 occasions, the plane was taken supersonic, then lowered to subsonic flight. But doing this stressed the aircraft, which was designed to be flexible. As a result, much of the thick white paint that covered the aircraft's surface flaked and peeled away. But all concerned would have agreed that it was a small price to pay to get the XB-70 past the speed of sound. However, for this aircraft to reach Mach 3, it would have to go much faster, and testing continued. October 24th saw the plane's 4th takeoff at approximately 40,000 feet. The folding tips, which had previously never been used, were lowered to the halfway position. This would improve the aircraft's stability and reduce the wing drag effect. At this stage, Cotton applied full afterburners to the six-pack, and the slender white shape of the Valkyrie began its steady increase in speed. On October 14, 1965, during its 25th flight, at an altitude of 70,000 feet, wingtips fully lowered, Air Vehicle Number 1 reached its goal, 3 times the speed of sound. But despite its technical success, and its success at meeting SAC's need for a heavy bomber many times faster than the B-58 Hustler, the Valkyrie was not destined to be adopted in military service. The Air Force, knowing the plane would not be accepted as a bomber, had tried to acquire 150 Valkyries for a reconnaissance role. but the survivability of high-flying planes over enemy airspace was now considered doubtful. Soviet anti-aircraft missiles had managed to down a U-2 spy plane which could fly at heights previously considered safe from any attack. Missiles also competed with high-speed bomber concepts within the US Air Force. The SAC now had intercontinental ballistic missiles to carry their nuclear bombs, weapons that were more economical and unstoppable than airplanes. From the early 1960s on, the ICBM was considered the primary means of delivering nuclear weapons. The ICBM also allows the Navy to play a role in strategic bombing, as its submarines offered platforms that were highly mobile and could not be detected. An enormous advantage that the Air Force bombers would not enjoy until the advent of the B-1B and the B-2. Like the XB-70, the B-1A was designed to replace the B-52 as the Strategic Air Command's high-altitude heavy bomber. However, due to political conflicts and technical problems, the project was cancelled. But the B-1 didn't die. Over the next several years, the US Air Force and Rockwell, the plane's manufacturer, revised the aircraft parameters. Taking full advantage of the aircraft's swing-wing potential, Rockwell redesigned the plane for long-range, low-level missions. The plane was outfitted with the latest detection evasion electronics. But the major difference between the B-1A and the B-1B is that simply the later model, although the product of considerable technical innovation and years of additional development, was actually made to be slower than its predecessor. Radar jamming and stealth technology have changed the specifications for strategic bombing aircraft. But this is a relatively new development. For much of the century, the military constantly sought faster and faster planes. The XB-70 faced an uncertain future. Despite the Pentagon's decision not to deploy its supersonic bomber, Air Force testing of the two XB-70 prototypes continued. One unique feature of the plane, the crew escape capsule, was a masterpiece of engineering. Should the Valkyrie depressurize, the capsule's clam-like top and bottom shells would automatically roll forward and completely engulf the crew member in an airtight module. From there, the pilot would still have limited control over the aircraft and, if necessary, the entire capsule could be fired from the plane into the air. These capsules were to play a very important part in the final chapter of the Air Vehicle No. 2. Seen here, with its slightly raised wings, the Air Vehicle No. 2 takes off on a routine test mission on June 8, 1966. Al White was in command, but he had a new co-pilot, Major Carl S. Cross, beside him. Cross was an extremely experienced pilot who had just joined the XB-70 project. At 8:27 in the morning after testing, the Valkyrie joined the formation with 4 chase planes. The event would be recorded by an accompanying Learjet. The exercise was simple enough and shouldn't have presented any problems. On the Valkyrie's inside right was an F-104, flown by test pilot Joe Walker. Walker, who was slated to join the XB-70 program, probably had more supersonic experience than any man alive. He recently completed a flight program on North American's X-15, the fastest plane on Earth. Flying below and slightly behind the Valkyrie's right wing, Walker's F-104 starfighter somehow veered too close to the Valkyrie. This shot, taken from the aircraft on the Valkyrie's left, is reversed to give some indication of what Joe Walker may have seen moments before his starfighter collided with the XB-70's wingtip. Possibly, the vector effect on the giant bomber pulled the little fighter into its massive wingtip. In any event, in the matter of seconds, the F-104 was hit and rolled into an inverted position across the top half of the Valkyrie's massive frame. As it did so, it struck both the XB-70's vertical fins and the left wingtip. Therefore, it fell thousands of feet to its destruction. Then, with a dreadful shudder, the Valkyrie rolled over and started on a steep spin. Al White reached for the ejection mechanism within his capsule and fired out of the stricken aircraft seconds before it struck the desert. His co-pilot was not so lucky and remained in the plane. Probably the G-forces of the descent stopped his ejection. By 9:36, Air Vehicle Number 2 was reduced to a smoldering carcass in the desert. Emergency helicopters rushed to the site, but there was little chance that Major Cross could have survived. However, about 10 miles away, the escape capsule containing Al White was spotted. Al was badly injured, and over the next several days, his life hung in the balance. His capsule had not landed correctly, but mercifully, his pilot seat had broken when it reached the ground, reducing the impact. Over the days that followed, technicians and project officials studied the records for clues, but the story was simple enough. Somehow, the little F-104 fighter had accidentally collided with the XB-70. And on that fateful morning, in one action, America lost 2 brave test pilots and one of the only 2 Valkyries ever to be produced. Al White, the Valkyrie's first pilot, and the man who flew more flights on the XB-70 than anyone else, recovered from the crash, but never flew the XB-70 again. After Air Vehicle Number 2 crashed, the remaining XB-70 continued to be tested over a period of 5 years. It was to log 83 test flights, and the research that it, and it alone, could do would provide valuable information for supersonic transport evaluation and many other projects relating to size, weight, heat, and speed. But in some ways, the Valkyrie had also been a military success. Years later, it was learned that the Soviet Union so feared the potential of the XB-70, but it had tried to develop its own smaller version. The Soviets' fear of the Valkyrie was also demonstrated in another way. For it's now known that the Russians developed at a tremendous expense the high-performance MiG-25 Foxbat. This fighter's sole function was to protect Russia from high-flying supersonic bomber aircraft. Aircraft like the Valkyrie. The paradox was that it seems likely that Russian scientists used North American vigilante bombers as patterns for the Foxbat. The similarities are just so close, both in size and in shape, that it seems certain that the Soviet designers used American research of the early 1950s to protect the Soviet Union from American bombers of the 1960s. Eventually, the one remaining Valkyrie was phased out of test service. Air Vehicle Number 1 landed for the last time at Wright-Patterson Air Force Base, home of the United States Air Force Museum. Piloted by Fitzhugh Fulton and Ted Stumfall, it was still collecting valuable data even on its last flight. Shortly before it was signed over to the museum curator, complete with its logbook and a brief ceremony, one of the pilots is reported to have said, "I would give anything to keep the Valkyrie in the air, except pay for it myself." The Valkyrie program has become expensive. The cost of the project, divided by the number of flights, costs American taxpayers $11 million every time it took to the air. But there can be little doubt that North American aviation engineers had not only achieved a technical wonder, they had produced one of the world's truly magnificent and unique planes.
So there were two XB-70s built only to be used for test, and they were extremely effective. They went 3 times the speed of sound, flew nearly to 80,000 feet, and the test program was very successful. Unfortunately, there was an accident in 1966 that had nothing to do with the test. It was an air-to-air collision. But the test program was extremely successful. And everything about the XB-70 is exotic. Every single thing about the XB-70. It had wingtips that drooped down to take advantage of something called compression lift. And basically the idea is the XB-70 at supersonic speed is creating these shock waves. And engineers figured out a way to harness those shock waves so that the XB-70 actually rides on those shock waves, and it generates additional lift. And the wingtips, which were alone as large as the wings on an aircraft, a smaller aircraft, would droop down and help contain that compression and take advantage of the compression lift. There was a large move in 2002, and the existing galleries were created, the Cold War Gallery, World War II Gallery, Korean War Gallery, and so forth. And the idea was to move all of the aircraft that were research and development, move them together in one place. And unfortunately, that place was on the guarded side of the base. But the idea was that when the next building was built, that then they would all move together as one unit over to the new building, rather than tear apart galleries, pulling R&D airplanes out of this one and that one. They would all come over here together. So to see the conclusion of that plan, the vision that was imagined 15 years ago, to see them come over here together and see the XB-70 move back is really very wonderful. Many of us have been waiting about 15 years for this to happen, so it's exciting. Another part of the XB-70 were its advanced engines. They were test engines. They were not production engines. In fact, there were only about 30 or so J93 engines built. It used a special fuel, JP6. And the thrust of a J93, one of these engines on the XB-70, is equivalent to the thrust on a frontline advanced fighter flying today. We've been very fortunate to be able to see some of these aircraft moving in and see this gallery beginning to form. We're very excited when we'll be able to show the public in 2016, and they'll be able to see the Research and Development Gallery, the Space Gallery, the Presidential Gallery, and the Global Reach Gallery. And the staff here is working feverishly to get to that date, and so the public can finally see these wonderful artifacts on display.
Her lines were sleek and powerful. She was designed to kill, to seek out and destroy an enemy bomber. She was the most advanced, the most sophisticated weapon of war conceived and built in Canada. She was the Arrow. On a February day in 1959, the conservative government of John Diefenbaker canceled the Arrow program after 5 of the aircraft had flown. Today, there are no Arrows. And there is film of the Arrow in flight, smuggled out of the Avro aircraft plant near Toronto in defiance of a government order to destroy not just the plane, but seemingly all evidence of its existence. Why did the government wish to eradicate its memory? The tragedy of the Arrow, like so many tragedies, began in hope and optimism. At the end of the war, Canada was in a position to become one of the world's leading manufacturers of aircraft. The Avro company, formed in 1945, was a symbol of faith in the future. We had been building Lancaster bombers for war. Now we would build both commercial aircraft for peace and fighters to protect the peace. The architects of this policy were a canny Canadian cabinet minister, C.D. Howe, and directors of a British aircraft firm, Hawker Siddeley. Among them, Sir Roy Dobson, the hard-driving Lancashireman who had virtually created the Lancaster bomber, and who now became Avro's first president. The company's first general manager, here on the right, was an impatient young Canadian, Fred Smythe. Avro brought together a talented team of young designers and engineers, many of them from England, like James Floyd. The age of the jet was beginning. But before the tragedy of the Arrow could unfold, another disaster was in the making. In 1946, the company embarked on its first project, a 4-engine passenger jet, which they hoped to sell to Trans-Canada Airlines, later known as Air Canada. TCA was intrigued by the idea of being the first North American airline to offer a jet service, intrigued and perhaps frightened. The company tried to market the plane in the United States. There was a triumphant publicity flight to New York, carrying the world's first jet airmail, and the New York Times said, "Uncle Sam has no monopoly on genius." Now, National Airlines ordered 4 of the aircraft, with an option on a further 6. The Korean War had started, and C.D. Howe ordered Avro to put his whole production effort behind a new fighter for the RCAF. Howard Hughes leased the plane for 6 months and used it as a personal toy. In 1957, the same year Boeing captured the market with its 707, the jetliner was broken up into scrap. Between the jetliner and the Arrow, there was one success story, the CF-100. In 1949, Avro had begun work on a new fighter. The National Film Board chronicled its birth in Screaming Jets.
Behind locked doors, Avro Canada worked to fill a top priority order from the Air Force. And now the reps are coming off Canada's hush-hush night fighter, CF-100.
The CF-100 was a twin-engine, 2-man day and night fighter, the first built in Canada to the RCAF's own specifications. It was eventually to be powered by the company's own Arenda engines. With the failure of the jetliner, Avro were now dependent entirely on military contracts, and the stakes were high.
In the expectant stillness of the hangar, the men who built the plane are tense with excitement. Each man wonders, had they miscalculated somewhere, or will it scorch off beautifully into the sky? Behind that sleek black question mark lay years of hard work and headaches for all of us.
And there were a few headaches to come. In 1951, the CF-100 was still a long way from its successful future. But it did bring into the company a handful of brilliant test pilots. Spud Potocki, a Polish air ace, Peter Cope from Gloucester Aircraft in England, Jack Woodman with the RCAF, who came later, and Jan Zyrkowski. These were to be the only 4 men to fly the Arrow. Zyrkowski could make the CF-100 do cartwheels in the air, and one day he even pushed it into a supersonic dive. But in 1951, another man was to have an impact on the fortunes of Avro and the Arrow. Crawford Gordon had been a protege of C.D. Howe's. At the age of 37, he came to the company as president and general manager. Together with Sir Roy Dobson, he built Avro into a complex of 39 companies. To Sir Roy, he was like another son, a son he would eventually disown. After Gordon's arrival, the CF-100 entered squadron service with the RCAF. Ultimately, Avro produced nearly 700 of them. But already the Air Force knew it needed something that would fly higher and faster to keep pace with the new Russian bombers. And in that knowledge was born the Arrow. In 1952, Avro came up with design studies for a new double-wing aircraft. The CF-105 was to be a supersonic twin-engine capable of engaging the enemy at 50,000 feet and carrying missiles and rockets. It was a whole new concept in fighter technology, and it pushed Avro's design team into finding solutions to problems never faced before. Jim Floyd was now Vice President of Engineering in charge of the overall design of the plane.
Problems were legion on the Arrow. We had a problem, for instance, at the wing skin temperatures at 50,000 feet, where the aircraft was to have its combat capability. were 40, 50 degrees higher than the boiling point of water. Yet inside of the wing, you had the fuel, which was cooling it down. So the differential temperature was trying to distort the wing. And we had to tailor and design the wing so that that distortion was compensated and didn't affect the aerodynamic capabilities of the aircraft.
There were to be no prototypes. Avro was going straight into a first batch of pre-production models, and testing was elaborate. Scale models were fired by rocket into Lake Ontario to test aerodynamic qualities. The CF-105 was now called the Arrow.
We had to be dead right first time. There was no flying a prototype, finding the problems on it, then reflecting that back into the production drawings and issuing modifications. You had to be right, and yet you had nothing to fall back on, no real experience to fall back on the design of this aircraft.
As the program developed, there were some unanswered questions that were to have a crucial bearing on the Arrow's fate. The RCAF had not completed studies on the weapon they wanted the plane to carry. Robert Lindley, chief technician, came up with an unusual solution.
One feature of the Arrow, the weapon bay, you may recall that the whole weapon bay would lower out of the airplane and go back in again. And I put that feature in there because I couldn't find out what weapon we were supposed to be carrying. So I said, okay, I'll solve the problem, I'll make a detachable portion. Take your time, make up your mind. When you're ready, we'll put it in there. And it was a nifty feature, I guess, in the end, but that's really why it was done.
While Lindley was coping with the unknown weapon system, the Arrow began to take shape on the factory floor. A workforce of some 14,000 men and women translated the engineering drawings into a reality of steel, aluminum, titanium, and miles of electric wire. The Liberal government of Louis Saint-Laurent began to notice the mounting costs. In mid-1955, C.D. Howe told the House, "We have embarked on a program of development that gives me the shudders." The RCAF had now decided it wanted the Sparrow missile and the Astra fire control system, neither of them yet off the drawing boards in the United States. The Air Force wanted the best, and it was going to cost the country dearly. But it was not the Liberals who were going to pay the bill. In June 1957, John Diefenbaker became Prime Minister of Canada at the head of a Conservative government, and suddenly Avro, created by the Liberals, found itself without friends in Ottawa. The Arrow was already a financial problem. Now, with hundreds of subcontractors dependent on the program, making everything from landing gear to delicate flight instruments, and with thousands of employees on the payroll, it was a political problem. On October the 4th, 1957, the Arrow made its first public appearance before an audience of dignitaries, Air Force officials, and workers. The Honorable George Perks, Minister of Defense in the new Conservative government, told his listeners that the coming missile age did not mean that the era of the manned airplane was over. The aircraft, he said, has this one great advantage over the missile. It can bring the judgment of a man into the battle. The argument which Perks dismissed was within months to be used against the Arrow by his own Prime Minister. But on that day, the builders of the Arrow were counting the months and the weeks ahead until it should take flight.
I understand the Arrow will undergo high-speed taxiing tests within the next 3 weeks. But when will it fly?
It will fly sometime during the period that it's undergoing these high-speed taxi trials. You say within the next 3 weeks. This is when we would hope it will be doing its high-speed trials. And sometime during that period, it will fly.
And it did fly. On the 25th of March, 1958, Jan Zurakowski climbed into the cockpit of Arrow 201. He made a final instrument check, pressed open the throttles, and released the brakes. The Arrow was ready for takeoff.
Start the photo for the guide detection. I am coming in to take photographs. Stand by it.
Every maneuver of the plane was recorded by cameras on the ground and in the two chase planes, piloted by Jack Woodman and Spud Potocki.
Controls are behaving quite nicely. I can see no oscillatory motion of any description in them. I think all this immediate the carriage is back to the authorization disappears. I think the carriage is making this. That's right, it's the side door which is making. The door which comes and closes the undercarriage in doing.
In flight, the Arrow performed like the thoroughbred she clearly was. All the attention to detail, all the elaborate test procedures of the past 5 years, paid off in a flight that was virtually flawless.
Let's go. They'll be accelerating up to 250 now. Roger.
In the laconic voices of Zurikowski and his countryman Spud Potocki, veterans of the Polish Air Force in Britain 13 years before, you hear the routine communication of two professionals examining the behavior of a piece of machinery as if this test flight were the most normal event in the world.
The engines are behaving quite nicely. They are occasionally giving a bit of a black puff of smoke coming out of them, Jan, but otherwise I can see there is no problem. That is Roger, Jan. As far as I can see from the back, no condition has changed. Switching over the dumpers now.
Fuel eggs, please, Joe. The wind is northeast at 0.
On that first flight of 35 minutes, Zurikowski took the plane to 11,000 feet. On succeeding flights, it was to reach easily its target of 50,000 feet at nearly twice the speed of sound. Workers and managers and Air Force personnel left their shops and offices to watch the return of Arrow 201. Some had even bought their families. But there was something else. Canadians, used to seeing the leadership in technology in the hands of the United States and Britain, were suddenly aware that they had something which looked like the best in the world.
And when Zora came down after this flight of this super airplane, and the snag sheet showed the malfunction of 2 electrical switches out of 4,000 or thereabouts, we weren't surprised. I'm not, I don't want to feel any arrogance about this, but the facts are we had done so much testing because of going straight into production that we had to be right. It was just unthinkable that anything could go radically wrong with that aircraft. And it was a very, very successful flight.
But first flight was very simple and very easy. From flying point of view, didn't present any problems.
Zurikowski never told you what the hell went on when you got him to fly an airplane. Because he flew them for himself, I think, not for you. But he was certainly a superb pilot. There's no question about it.
Reg Lane was a group captain in the RCAF attached to the Avro plant and the Arrow program. He retired as Brigadier General Lane, Deputy Commander of NORAD at Colorado Springs. He was one of the spectators in that crowd on the edge of the runway.
It was absolutely magnificent when that aircraft flew the first time, and the reports that were coming back from the test pilot, and the various readouts of the test equipment that was on board the aircraft, of the performance of the total machine. And of course, I think it was a second or third flight, I can't remember precisely, when it actually went through Mach 1. Now, that was a truly incredible accomplishment and in those days, and at that stage of the design of modern jet airplanes. Truly phenomenal effort. Well, of course, everyone's spirits just rocketed when the initial reports came through on the first test flight of the airplane. And we knew that we had a winner.
It was a fantastic performing aircraft. I mean, Avro's commitment was to build an airplane that would give the Air Force 1.5 Mach. Our performance boys thought we could do 1.6 Mach with it. As it turned out, we actually flew that airplane to 1.9 Mach number. And had we continued to develop into the Iroquois engine powered airplane, we had a lighter engine for more thrust, and we had a 2.3, 2.4 Mach number potential. And in 1958, there wasn't another airplane in the world that was anywhere near being competitive with this airplane.
The project was just had a lot of national pride. You know, you just go home at night and people want to hear about it, and you tell them about it. I remember Bob Rice had a garage down the road from the airport, and he used to call me. I was taking off today, and I'd say, yeah, take what time? I said, I don't know, probably about 10 o'clock. And he'd be out in front of the garage with his people. He wouldn't serve anybody no gas, waiting for the airplane to take off and go over a gas station. For the airplane, that's what everybody wanted, you know. It was something they could look at and say, hey, that's what we did in this country, and I think it was terrific.
Through the summer of 1958, Arrows 201, 202, and 203 chalked up 57 flights, totaling some 61 hours. Each flight provided valuable lessons about the plane's capabilities. 204 made 6 flights beginning in October, and 205 flew only once on the 11th of January, 1959. But by that time, the Arrow was already under sentence of death. In the summer of 1958, General Perks and Finance Minister Donald Fleming had made an official visit to NORAD headquarters in Colorado. The American plan for North American defense included Canadian fighter squadrons, the radar warning system, and the Bullmark missile. Perks now became convinced that the bomber was becoming obsolete, that if Russia were going to attack North America, it would do so with nuclear missiles. The Arrow would be useless against such an attack. If fighters were needed, he now had assurances from the Americans that the United States could make them available in quantity. The logic of this was not lost on his colleague, the Minister of Finance.
The plane was becoming much more expensive to construct than had ever been expected in the first place. Indeed, originally, thinking in terms of manufacturing a much larger number of planes, the cost had been estimated down as low as $1 million a copy. Well, because of the disappearance of the hoped-for market, the cost was getting up to figures between $8 million and $12.
In September 1958, the first blow fell. The Prime Minister announced that because of the rapid development of missiles, her government was not going to complete the full Arrow program. Crawford Gordon chose to believe the Arrow would not be cancelled.
I want to stress most emphatically that the Arrow program has not been canceled, nor has it been decided not to put it into production. On the contrary, the Prime Minister's statement says the program is to continue. As it now stands, it involves the building of 37 aircraft and an appropriate number of engines. This situation remains unchanged, and we are convinced that when the review takes place next March, the Arrow will be ordered into production.
But General Perks spells it out. The Sparrow missile and Astra fire control systems were to be dropped. Work would continue on the 37 pre-production models, and that was all.
Everybody in the country buried the Arrow. They said it was all finished and so on, but we weren't prepared to accept that, and we went about our business to try to find out. We spoke to the political people in Ottawa on the one hand and the military on the other, and got two completely opposite.
Now the company mounted a desperate campaign to reverse the decision. Fred Smythe went to Washington to see the Assistant Secretary of the Air Force and extracted from him an extraordinary commitment. The U.S. Air Force was willing to fund the missile and fire control system, as well as supplying test facilities as a virtual gift to the Government of Canada, and he authorized Smythe to communicate this to the Minister of Defense Productions, Raymond O'Hurley.
On the next day, I went to Mr. O'Hurley with a letter to this effect, and I stood there while he read it. And that was the last we heard of that.
No trace of that letter can be found in the National Archives. Indeed, Mr. Perks later denied that there had been any offer of financial help from the Americans. If an air of mystery hangs over many of the decisions in the Arrow story, it is because so many files are either incomplete or closed to the public. In any case, it appears that the letter would have made no difference. The government had already made up its mind. February 20th, 1959. For the thousands of people who were thrown out of work that day, it would be known as Black Friday. More than 20 years later, the memories are still fresh and painful.
Well, about 9:30 in the morning, one of the fellows in the office telephoned his broker, just an ordinary inquiry on some stock prices. And toward the end of the conversation, he said, so by the way, how's Avro Canada doing today? Now you have to bear in mind that there's a tremendous feeling of pride at working at Avro Aircraft and Doranda engines at that time. People really enjoyed it, and they bought stock in the company in hopes that they would, succeed while the company succeeded. And at any rate, the broker said, let's see, Avro Canada, oh, just a minute, there's something coming in over the ticker tape. And see, waited a couple of minutes, came back, and he says, we just got a thing over the ticker tape that says that the Canadian Prime Minister has just announced in the House of Commons that the Avro, Arrow, and Doranda Iroquois programs are to cease immediately. And that was the extent of the thing on the ticker tape. So the guy came back off the telephone, sort of quite shaken, obviously.
Be about 10:30, just after 10 in any event. As I stepped out in the hall, coming running down the corridor, very white in the face, was Joe Morley, who was my vice president of sales, followed by Alan Hoare, who was the DDP representative in the company. And Morley said, the Prime Minister has just announced in the House of Commons that the Arrow, the Iroquois, have been cancelled.
2 hours later, around noon or after, Mr. Plant came on the loudspeaker system and said that everything had been canceled, every single contract the company had on the Arrow and on the Iroquois engine. And he read the telegram, or cable, which was sent, and he said that under the circumstances, and with no other contracts to fall back on, of the kind that they had been pressuring the government to let them begin and take men off the Arrow to start work on, he had no alternative but to lay everyone off for the time being until they sorted out union priorities, seniority, and what jobs they could salvage that could keep a few people busy, and that they would be called back after this was sorted out.
When I got there, all the executives, the ones who were left, were all standing round there with a drink in their hand. This is 10 o'clock in the morning, and some were partly loaded. And Gordon, we're waiting for the telegram to arrive. We'd had it officially over the phone. And when it came, Gordon read it, and he handed it to me, and he said, somebody has got to take on that son of a bitch in Ottawa, and I'm just the one to do it.
Mr. Diefenbaker had said later that the abrupt dismissal of 14,000 people was an attempt to embarrass the government.
Yeah. Well, we were only an agent of the government. Anyone with any knowledge of government contract procedure or industrial practice would know that we had no alternative. The men were to stop work then, and they weren't to be paid then. There were no further costs to be incurred as far as the government was concerned. So you tell me what you do with 13,000 people with nothing to do.
A sudden decision like this, it's got to cause panic in the place. That's for sure. I mean, whose side is he on? Is he trying to break he's trying to break the country, in my opinion. And $100 spent in this plant brings $65 back in taxes. That's been explained to all the public. He's going to give all those hundreds to the states. For why? Are they backing him?
I would just like to say that I feel Mr. Diefenbaker
has sold his country and his fellow Canadians down the river to American interests.
I just have a couple of words to say to Mr. Diefenbaker. Be a Canadian, buy Canadian.
Brampton is probably typical of scores of other Canadian towns.
And Cancellation created shockwaves in communities around the Avro plant. For CBC News, a young Mormy Safer reported on its effects on the lives of workers and their families.
And their independence. Well, in fact, Brampton is dependent on one single industry. Small talk and gossip cover a single topic today: the end of the Arrow.
It's probably one of the more emotional sort of experiences I've had in my life, I think, in a sense, because I think partly because of the tremendous personal involvement of everybody who worked there. There was I mean, if you can imagine secretaries walking out from the design floor down the stairs, you know, with tears streaming down their faces and this sort of thing. And it wasn't just a few isolated ones, it was a lot of them. You know, it was a very sort of emotional upheaval, I think.
For weeks after that, people would wander into work just at a normal work time, just couldn't believe it had finished. You know, they'd walk around in days almost. They'd come in and sit at the boards and walk around just as if nothing had happened. And there were about 5, I don't recall the exact number, but there were about 5 of us left there, try and pick up the pieces and put the engineering together and package it and put it away so that it'd be left for posterity or burnt, maybe burnt.
And in fact, the saddest thing on Black Friday was that when we were in with the president of the company and we were holding a wake, if you like, on the announcement, and I couldn't believe it. I just went to, you know, almost was sick on the thing of what do we do with all these people and what do we do with my 1,500 engineers. My chief engineer came in, who had been preparing the 206, which had the Air Corps engine in for first flight. And he said, I've heard about the cancellation. Can I fly 206? In other words, can I continue with the preparation of 206 for flight? And after consultation with Johnny Plant, who was the president of the company, and the other directors, I just had to go and tell Bob Lindley, no, you can't fly that aircraft. So in fact, the aircraft, which would have bettered the specification, was a phenomenal aircraft, an all-Canadian project with a Canadian airframe, Canadian engine, never flew.
In a warehouse in Ottawa is all that remains of Arrow 206, the plane that never flew. There are those who believe that with the Iroquois engine, it would have set world records for altitude and speed. And the Iroquois? It's now an exhibit in the aeronautical collection. There is no plaque to identify it. It seems a curious way to honor our achievements. And we still ask the question, what finally killed the Arrow?
I think it's a very difficult question to answer. I felt personally, even though I was involved with it, the program should never have been started in Canada in the first place because it was just too expensive for us. However, it was started, and if they'd maintained it at its original idea, this might have gone through. But then when they added the cost of developing Sparrow 2 and the cost of the Astra fire control system, this just added to the cost. And if they hadn't been added, whether this would have made a difference, I don't know. But the other thing is that if the two opposing people, and let's face it, there was a lot of personalities involved in the cancellation with Mr. Diefenbaker and Crawford Gordon. And if either one of those two people had been different, and preferably both of them, the cancellation could not have happened. I think it was a very personal thing on this, in the final cancellation of the Arrow.
Men of different temperament, different background. Gordon, contemptuous of the prairie lawyer who didn't understand industry. Diefenbaker, suspicious of the aggressive tactics of a Bay Street whiz kid. There were stories of a famous meeting in September of 1958.
Although I'd never met Mr. Diefenbaker, I knew he had great respect for his office, for the office of Prime Minister. And I warned Gordon before he went to see him not to take a drink and not to smoke in his office, whatever he did. Well, Gordon must have been very belligerent. He had his half loaded when he got there. and he puffed smoke in the old man's face all the time, and it ended in quite a bitter argument, and what you would use the term that the president was thrown out.
But, you know, what's that got to do with the air defense policy of the government of Canada? Whether or not Diefenbaker and Gordon had a personality clash, the only time they met was on that occasion, September the 17th, for about 20 minutes.
That was their only meeting?
Yes. And what's it got to do with the air defense policy of Canada, or the Arrow, or anything else?
I haven't any idea the real reason for the cancellation. So many reasons have been given. Mr. Diefenbaker even said that the chiefs of staff said he didn't want the airplane. Well, I don't believe that. I think the real reason for the cancellation was the fact that they weren't sure that it was going to cost what we thought it was going to cost. And secondly, that Mr. Diefenbaker wanted to save some money somewhere. What is going to be done with the money, I don't know. But it has been stated to me by a man who now past the Great Divide, who was in the know, that for about $50 million more than we'd already spent, plus the cancellation charges which we were going to spend, that we could have had as many arrows as we had voodoos.
2 years later, Canada took possession of 66 second-hand voodoos back from the Americans in a package deal. And the voodoo was vastly inferior to the Arrow, but the price was right. And what would C.D. Howe have done had the Liberals remained in power? In January 1959, he wrote to his leader, Lester Pearson, "There is no doubt in my mind that the CF-105 should be terminated. Costs are completely out of hand." In this, the Liberals and the Tories were in agreement.
It was an inevitable decision. No other decision under the circumstances could have been responsibly made. Had we done something else, it would have simply meant taxing the people of Canada to go on manufacturing planes for which there would never be a market outside Canada. And the Royal Canadian Air Force could only absorb so many. And as a matter of fact, it was around this time that the whole role of the fighter aircraft had to be re-examined, because our concept of the defense of Canada in relation to a possible attack changed from fear of the man bomber to fear of missiles. And the Avro Arrow would never have been any use to us as a defense against missiles.
Last September, I made it perfectly clear that having regard to the development that was then taking place, particularly in intercontinental ballistic missiles, that there was a probability that action would have to be taken in this regard. And that's the reason for the action. We were loath to take it.
The Prime Minister used not money, but the missile threat as the major reason for the cancellation. In place of the Arrow, we acquired the Beaumark missile from the United States.
The part that upset me was basically in being asked to give some rationale behind the decision other than cost. And we really couldn't do it because it was simply a cost matter. And then Mr. Diefenbaker making the statement that the introduction of the Beaumark was the reason for canceling the Arrow, that it was a better interceptor, if you will, and more effective, and therefore the Arrow could be canceled. That argument was a very specious one, and literally had no fact whatsoever.
The RCAF was caught in the politics of the cancellation. Air Marshal Campbell was accused of not fighting hard enough for the Arrow. The Chiefs of Staff did not make a recommendation to cancel the Arrow, and that he offered his resignation if the Arrow were cancelled without provision for an alternative fighter. The alternative was the Voodoo and the Beaumark. And the Beaumark was a failure. This model met the same fate as Arrow 206, lying a few meters away in the same warehouse. Whatever the Beaumark was, it was no replacement for the Arrow. There was still another reason offered by the government for the cancellation. They tried to sell the Arrow before it entered squadron service, and they found they couldn't.
Now, I went down to the United States in September and had conversations with their Secretary of Defense, find out whether they would be interested in our 105, see whether they'd be willing to purchase the 105 for even some of their squadrons. And the answer that I received was that they were not prepared at that time to do so.
Mr. Perks, I reiterate, is a gentleman. I have the highest regard for him as a person. But he was a permanent Army officer. He'd been retired from that for some time. He was over 70 years old, and he didn't know one end of an airplane from another. He had no appreciation of the industrial implications. He wasn't in a position to discuss the Arrow or any aspect of it.
There was another attempt to sell the Arrow. In the winter of 1958, Donald Fleming and 2 other ministers met with their American counterparts in Paris to discuss defense. Fleming told them that the future of the Arrow might depend on sales to the U.S., or it was hardly a strong selling point.
At the conclusion of my statement, Mr. Robert Anderson, the U.S. Secretary of the Treasury, who was my opposite number in that committee, gave me the answer no. It was an unconditional, uncompromising, and final answer. It was the decision of the United States government not to purchase the Arrow. And that decision spelled the doom of the Arrow program.
Tall Hellyer, who later ran as a conservative, was Liberals' defense critic in opposition in 1959, and he still maintains that the government did not make the right kind of effort to sell the Arrow.
I don't think the Arrow could have been sold to the United States directly because the United States Air Force has an almost iron rule. They never buy anything that isn't invented in the United States. But what they do, and what I think might have been done, is that they sometimes help finance sales to other allies. And it's my belief that if Mr. Howe, for example, had still been around, that he could have done something. At that time, Canadian real estate was still important to the United States. It's not now, but then it was. They had to count on us for the radar lines and for a number of other facilities, for refueling facilities and so on. And we had a lot of leverage. We had a lot of power at that time in negotiations. And I think someone like Mr. Howe could have said, all right, you won't buy it. This we understand. This we know. But we want your help in financing the sale of this aircraft to some of the other allies that you traditionally help. And with his kind of persuasion, I personally believe that it could have been done.
Yes, on balance, I think it could have been sold. When you look at the attempts of the French to sell Mirage fighters or other countries to sell weapon systems, you get the tremendous involvement, not only at the business level, but at the most senior political levels, where a prime minister or a president will go out to sell a program. I don't think in this country that we've a tradition of involving the senior political community in selling weapon systems. And I think if that kind of pressure had been applied in relation to the United States, where there was a gap in weapon systems that the Arrow could have filled, I think that could have been done. And it's a lesson we still have to learn, that if you're going to sell major programs, then you need major political effort in support of those programs.
Its performance, even in the curtailed flight tests, placed it among the best in the world. Men who had worked to build the planes were now ordered to cut them to pieces. As to who issued the order, whether it came from cabinet or from a bureaucrat, no one is telling.
In Mr. Diefenbaker's memoir, I think he said that he was not aware of these instructions. But I was aware of them because I was the fellow who received them. And like an idiot, I folded. And so I'm the person that issued the instructions to destroy the airplanes.
Cameramen were not allowed inside the plant to record the destruction, but one enterprising photographer rented a plane and took aerial shots.
They were cut up with torches in the hangar then, and hammered down with steel balls like they destroy buildings.
After the aircraft were dismantled, the pieces were sold to a Hamilton junk dealer for 6.5 cents per pound. A few weeks earlier, a request for one or more of the arrows had come from Britain for use in flight testing. The request was not refused. It was simply withdrawn.
3 could have been flown to England with 2 more to be used as backup spares of the first 5 we had flying. Canada wouldn't let them go. I mean, the reason is obvious. Had those aeroplanes ever got to Farnborough, and Farnborough realized the fantastic performance, I mean, Diefenbaker in no way have ever justified his cancellation of that program. No, I'm sure that's why they were never let go.
Well, the 5 arrows that had flown, and for which there was some interest on the part of the Royal Aeronautic Establishment in Britain, they would wanted to take a couple of those and work further on research with them. Those were destroyed. Those were cut into scrap.
Well, I can't give you the detail now of the issues that went into the destruction of a particular copy. But I can tell you that in general, there was no deliberate destruction to do away with the arrow. Far from it. It was just a case of what was the economical way of disposing at that particular time of various copies of the plane that were in various stages of production.
And as you know, what happened after that, it was just like a de-Stalinization program. We were ordered to destroy all film on all original negative film on the Avro, all the still pictures, black and white, all stuff that had been developed during the flight test phases of the airplane. Ottawa's instructions were to destroy these. They ordered us to destroy the airplanes by breaking them up. And I think the day I saw that production line being put to the cutting torch, it's the nearest I'd come to shedding a tear over an airplane. It was pathetic.
Did you see any aircraft being destroyed?
No. No. I could have if I wanted to, but I didn't. I couldn't. I don't think any people want to go and watch such a massacre. Frightening sight.
It's not, in my view, something that one can be dogmatic about, but I would certainly come down on the side of saying, yes, painfully, regrettably, it was the right decision at the time under all the circumstances. And I think so now, too.
Well, you've got to look at it from various points of view. You know, from the country's point of view, was it a mistake? I think that you really can't afford to abdicate from the thrust of technology. The airplane was a good airplane. It probably would have sold a hell of a lot of copies.
If you have to look at it strictly from the standpoint of defense, and the amount of defense dollars that the Arrow was going to take, then I don't really think that the government had any choice. Certainly, it would have taken all of the defense money that was then available. The Navy and the Army would have had nothing. They would have been totally bereft for years. And this, from their standpoint, I think was untenable. If you look at it from the national standpoint, in other words, you ignore the defense budget and say, what is the best thing for Canada, for our industrial base, for our scientific base, for our national base, our feeling of Canadianism, for the great things that we're capable of doing, then personally, I think it was a disastrous decision.
Well, again, looking back, the enormous loss that we have endured in the people and in the technology, one wonders if it would not have perhaps been worth it to have accepted those higher costs at that day to retain that type of talent and technology here in Canada. But that's hindsight, and hindsight's 20/20 vision. And in those days, I don't think anyone really appreciated the impact, the enormous impact downstream, 10 years, 15 years later, of that decision.
And the consequences? One of them was a shot in the arm for the American Moon project. A number of top engineers were immediately snapped up by NASA. Brian Erb, a young engineer, developed the heat shield for the Apollo spacecraft. Len Packham, in charge of the rocket test program with Avro, worked on the telemetry system for the first manned rocket launchings. And Jim Chamberlain, chief technician at Avro, was project director for Gemini. Engineer Ken Cook went from Avro straight to McDonnell Douglas in St. Louis. He's now a systems engineer on the F-18, which his company hopes to sell to Canada for $2.5 billion. Can a country the size of Canada ever compete in the business of building costly weapons of war?
The immediate impression is to say, no, you can't afford them. But when you look at Sweden, which has a third our population and which has an incredibly strong aircraft industry, they have managed to establish a strong defense program, a stable planned program, a very strong aircraft industry. And although they're in some difficulties now, they've done that for the last 20 or 30 years. So it simply is feasible if the planning and the purpose is there over a sufficiently long term.
But I think it's a characteristic of Canada. We really haven't learned to capitalize on the genius that we're able to create from time to time in this country. We don't support research and development. We go so far and then back off.
Canada can do it if it wants to be in that kind of business, if it wants to build its economy, if it wants to develop that sense of commitment, then we have all the other resources that are available to do it. The manpower, the finance, the marketing ability is all there in a native sense.
The end of the Arrow was to be the end of the company. It was also the end of Crawford Gordon. Sir Roy Dobson, wheeling and dealing to keep the company alive, fired the man he once thought of as a son, and felt compelled to write a letter to John Diefenbaker.
It's addressed to the Right Honorable John G. Diefenbaker. It begins, Dear Mr. Prime Minister, I sent word via Mr. Guest that I have asked for and received the resignation of Mr. Crawford Gordon as President of Avro Canada Limited on the grounds that I was most dissatisfied with the way he has been working and with his actions, which could not be considered to be in the best interest of the company or the country. It's signed by Sir Roy H. Dobson, by Roy H. Dobson.
8 years later, Crawford Gordon died in New York. His friends said he drank himself to death. He could handle success, but not failure. And what of the other personalities in the Arrow story? After the cancellation, James Floyd moved back to Britain. In a distinguished career, he saw two of his aeroplanes, both of them pioneering ventures, both cancelled. Ferd Smy bought an office equipment company, got tired of it, and in 1972 moved to Portugal. Jan Zurikowski retired a few months before the cancellation. The Arrow is long dead, but the controversy lives on with its memory. People still argue its merits. Was it as good, as great as its supporters would have us believe?
Here are three answers.
If you mean by the Arrow, I take it a fighting instrument of war, which must include an aircraft, an engine, and a sophisticated fire control system, then of course there never was an Arrow in those terms. I think everybody will agree that is factual. But I think it's a mistake and gets people somewhat worked up in a way that they ought not to talk about the cancellation of this great Canadian achievement when in fact it may very well have turned out to be a great achievement, but it seems to me that at the time it was canceled, it was too soon to say whether the hopes that everyone held out for it were going to be realized or were not.
Aircraft nowadays are maybe more sophisticated in this or that, and better engines, better fuel consumption, better pressure recoveries. But there's nothing that I know of that would, even now, today, be an improvement on that maneuverability capability.
It was absolute state of the art. It was a beautiful machine, and we probably would still be flying it today.
Controls are behaving quite nicely. I can see no oscillatory motions of any description in them. I think all this, the militant carriage is fact that all the vibration disappears. I think the carriage is making this. That's right, it's the side door which is making. The door which comes and flows behind the carriage in the wing. It's hitting against the fuselage. Engines are behaving quite nicely. They are occasionally giving you a bit of a black puff of smoke coming out of them, but otherwise I can see there is no problem. I think it's still got a bit less 1.5 degree. Sorry, side slip to right. That is rudderly, and as far as I can see from the back, no condition has changed. Switching out the dampers now.
Fuel readings, please, 201. The wind is northeast at 10, the altimeter is 0 and number 1 to 32. Telemetry is touchdown.
Aviation, the art of aeronautics, began with the dreamers, inventors and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.
As one of the missing Century series fighters, the XF-108 long-range